Okay, our goal for today's lesson is to just multiply matrices together. We did multiplication yesterday, but just to be very clear, hey guys, you're going to want to transition into the notes, so you're going to get behind. What I need to go ahead and talk to you about is, we did multiplication in class yesterday, but we did scalar multiplication in class, where we had to take a matrix and multiply it by a constant. Today, we're multiplying entire boxes of numbers together, and I'll give you a little spoiler alert. It actually works a lot more like FOIL than it does just straight multiplication. Do you guys remember FOIL from Algebra 1? Not only did you have to multiply when you FOILed, but you also added your F plus your O plus your I plus your L. Very same idea in today's lesson. So I just want to keep that in mind. Like I said, our goal for today is to multiply matrices together, and I give you two ways to do it. One way is on your calculator, the other way is by hand. So we'll talk a little bit about that. Before we actually jump into doing matrix multiplication, though, we have to decide if it's possible. And the rule we follow in order to decide if matrices actually can be multiplied together is the number of columns in the first matrix needs to match the number of rows in the second matrix. Right? I know. It's a lot to remember. So what I've devised over the years is an easy way to figure out if your matrix multiplication is possible. What we're going to do, we're going to draw smiley faces. You ready? Here we go. I'm going to start with part B, because part B is a case where matrix multiplication is possible. So let me show you that first. What we'll notice here, I'm going to draw some eyes, right? Because whenever I draw a smiley face, I always draw the eyes first. We draw the eyes by circling the inside numbers in the problem. Those are two eyeballs. So matrix A is a 3 by 3 matrix. It's got 3 rows and 3 columns. Matrix B is a 3 by 2 matrix. It has 3 rows and 2 columns. So do you see what I circled here for my eyeballs? The number of columns in matrix A and the number of rows in matrix B. Since those eyeballs match, both numbers are 3, that's what tells me the matrix multiplication is possible. Our product matrix AB will be defined. Gets better though. Smiley faces, you need a mouth, right? So we can draw our mouth in. There's the mouth. You see it? That mouth, so if the eyes match, I can draw the mouth, and the mouth actually tells me how big my answer is going to be. So the product matrix in this problem is going to have 3 rows and 2 columns. It'll be a 3 by 2 matrix. So let's make that official. Here in part B, they give us some fill in the blanks there. And we could say because matrix A is a 3 by 3 matrix and B is a 3 by 2 matrix, the product AB is defined, and it will be a 3 by 2 matrix. Now looking at part A, I go to do the same thing. I'm like, okay, well I'm going to draw some eyeballs. So I circle the innermost numbers in the problem. I'm like, wait a second, 3 and 4 are not the same number. The number of columns in matrix A doesn't match the number of rows in matrix B. So this is the case where our matrix multiplication is not defined. And the reason is the number of columns in A, which was 3, differs from the number of rows for the product AB is not defined. So we wouldn't be able to get an answer. Your calculator will say dim mismatch. The product won't, you can't find it. And you'll see why is that when I do matrix multiplication by hand, it starts to kind of make sense as to why it wouldn't work. Okay, so in words, how we do matrix multiplication by hand is kind of outlined in that little bit of a sentence there. To find the elements in the ith row and jth column of a product matrix AB, we multiply every element in the ith row by the jth column, each element, corresponding element in the jth column, and then we add those values together. So that says ith row and jth column. Don't worry, I will make that easier. But that's the official math speak for how you do it. On our calculator, we are going to press second and the x to the negative first button. And what you'll see above that x to the negative first button is the word matrix. Now, why these two buttons are tied together, why our engineers at Texas Instruments did that, becomes very clear in tomorrow's lesson. Those two buttons we use quite a bit together, those two functions, so they put them in the same button. So we're going to start just by doing matrix multiplication on our calculator. And what we're going to go ahead and do right now is find product matrix AB. So first things first, let's decide if this matrix multiplication is actually even possible. I notice matrix A has 2 rows and 2 columns. So matrix A is 2 by 2. I also notice that matrix B has 2 rows and 2 columns. So if I draw my eyeballs, I notice the inside numbers match. So the product AB will be defined, so we will be able to find AB. And furthermore, when I draw the mouth, I'm coming to understand that the product matrix will also be 2 by 2. In other words, it's going to have 4 elements. So we're going to make our calculators do the legwork on this problem. We're going to make our calculators figure out the product of matrix A times matrix B. To do this, you're going to press second and x to the negative first on your calculator. Go ahead, take a second and do that. And then you'll see like A, B, C, D, E, F, G come up on the left-hand side of your screen there. And you're hovering above, it's darkened, it says names. I need you to arrow over 1 time to edit. And we're going to edit matrix A, because we get to type the stuff in, right? So you arrow over to edit, and you choose matrix A. And now we have to key in the dimensions. That's the size of matrix A. Well, remember, matrix A was a 2 by 2 matrix. So you're going to press 2, enter, 2, enter. And that'll bounce you down to the spot where you got to type in your box of numbers. In your box of numbers, you're supposed to type 1, enter, -2, enter, 5, enter, and then -4, enter. So you're just keying in your elements right now. Little data entry for you. Is anybody having trouble editing matrix A? Okay, now we have to edit matrix B. So you're going to hit second and x to the negative first. That gets you into your matrix menu again. Arrow over to edit. Scroll down to B and select that by pressing enter. And matrix B is also 2 by 2. So you're going to press 2, enter, 2, enter. And that'll bounce you down to the spot where you can enter your 4 elements for matrix B. So you have to press 3, enter, -6, enter, 7, enter, and -1, enter. Anybody having trouble editing matrix B? Now you're going to press second, quit. This takes you to what we call our home screen. It's where we do all of our operations, right? Like if I asked you to do 15,312 times 782, you would do that in your home screen. Well, matrix multiplication also gets done in your home screen, but we need to call our matrices into that screen. Well, when you call something up into your home screen, you call it by name. Like if I see Noah in the hall, I'm like, "Hi, Noah," I'm going to call him over by name, right? If I need him to do something. Well, we need to call up matrix A by name. So what you're going to go ahead and do is press second and x to the negative first. And then, do you see how names is darkened? Just press enter, and then A should just bounce into the top right-hand corner of your home screen. Okay, then we're going to press times. And then you're going to go second x to the negative first to get into your matrix menu. And this time you're going to go down to B and press enter. And then B should bounce into your home screen. If you press enter again, your calculator will work to find the product matrix AB. Copy. Olivia's here. She got hers right.
Whoa. what does it actually do?
Yeah, that's a great question. We're about to do the next one by hand. So I'll show you what your calculator's doing. So Parker, what I also hear of value in your comment is it's not really intuitive as to what your calculator is doing, right? Where does it negative 11 come from? Yesterday's lesson was so easy because all we were doing when we were adding is adding like 1 plus 3 and negative 2 plus negative 6. But I think what Parker's noticing is that, like, to do matrix multiplication, we're not doing 1 times 3 and then negative 2 times negative 6. We're actually doing more of a foiling. We're distributing the elements to each other and adding. It's different than scalar multiplication. So it's good that you noticed that because there's more going on. There's more to the story for sure. So did everybody get their answer for AB? Did anybody not get that on their screen? If you didn't get it, chances are you just typed in a number wrong or have you slipped a negative or something like that. Wow, nice job, guys. Okay, so now what we're going to go ahead and do, I'm going to let you practice for just a second. I want for me to find matrix, the product matrix BA. So practice calling B times A into your home screen. So you're doing B times A. Okay, when you find matrix BA, we do have another question being asked of us here. It's asking us, is matrix multiplication commutative? What do you think? No, it is not. Yeah, A times B is not the same as B times A when we talk about matrices. So once again, you're probably saying, why is that, and where are these numbers coming from? So, don't tell me the answer just yet for BA. I want to see if I can produce it by hand. So what we're working on together right now, I had to copy this down because it takes more space. You do not have to recopy B times A. But what I want to show you is how to find BA by hand. You ready? We're going to multiply B times A. So these are the notes you're going to take. All right. First things first, I noticed matrix B was 2 by 2. And matrix A was 2 by 2. So the matrix multiplication was not only possible, but my answer matrix, again, had to be 2 by 2. So what I'm going to go ahead and do is open up my product matrix BA. It's a 2 by 2 matrix. So do you see how I have 2 rows and 2 columns? I got that from connecting the numbers for the smile. That's where that 2 by 2 came from. Now, I'm going to give each element in my product matrix a name. Not like George or Henry, but rather I'm going to call them by their position numbers. So for instance, this element right here is in the first row, first column. So I'm going to call that element 1, 1. It's like I'm giving it an ordered pair. And then the next element to its right is still in the first row, but it's in the second column. So that's going to be element 1, 2. And then if I bounce down to that third element that we're kind of staring at right now, that's in the second row, but it's in the first column. So I'll call that element 2, 1. And then that fourth element, anybody know what that element's name would be? Go ahead, Everett. 2, 2, yep. Because it's in the second row, second column. Remember how the direction said ith row, jth column? Okay, this is what they're talking about. To find element 1, 1, to find this element right there, what they're telling me is I have to multiply the entire first row by the entire, first row of the first matrix times the first column of the second matrix and add. So watch this. I have to multiply the first row by the first column and add. So let's do that. I'm going to multiply. My first row is 3 times 1, which is 3. So first row, first column. And then negative 6 times 5 is negative 30. So I'm thinking your calculator gave you a first element there of negative 27. Did we get it? Is that right? Mm-hmm. We're going to do this 3 more times. So once again, just retracing what I just did, because this was element 1, 1, I had to multiply the entire first row of the first matrix times the first column in my second matrix. And then I had to add. Okay, wait, let's do it again. So now I need to find element 1, 2, which means I'm going to multiply the entire first row by the entire second column. First row by the second column. So let's do that. First row is going to be 3 times negative 2. That's negative 6. And then negative 6 times negative 4 is positive 24. So I should have 18 as my 1, 2 element. Am I still right?
Wait, which one did you multiply?
So this is element 1, 2,
Yeah.
which means I'm doing the first row by the second column. 1, 2. Okay, now this element here is 2, 1, right? So now I have to do the second row by the first column. Second row by the first column. So let's do that. So that's going to be 7 times 1. That's 7. And then negative 1 times 5. That's negative 5. So 7 plus negative 5 is 2. All right, last one. Anybody want to help me with this? I've got to find element 2, 2. So what do I need to multiply together? You guys are writing. Go ahead, Cassidy, let's hear it.
Negative 1 and negative 2, and then 7 and negative 4.
Good. Good. So we're going to do the second row by the second column. So 7 and negative 2. Excuse me, 7 times negative 2 is negative 14. And then negative 1 times negative 4 is 4. So that last element should be negative 10. So that's what your calculator hopefully came up with. What's up, Parker?
Wait, does it matter like what order you do it in?
Yeah, because matrix multiplication is not commutative.
No,
Order is
no,
important.
Like, if you like 2, 2. Like, what if you did like 7 times negative 4? And then negative 1 times negative 2.
So 7 times negative 4 gives you negative 28. And negative 1 times negative 2 is 2.
Like,
So yeah, that's not going to work out, huh?
it looks like the right way.
It looks like the right way. Oh, okay, this will help. Also in the words, it does say corresponding, right? So we have to kind of go in order. So if I'm naming elements, for instance, in the second row of this matrix, I read that as 7, negative 1. I don't read that as negative 1, 7. Okay, that applies to columns as well. If I'm reading this column, I don't read it as negative 4, negative 2. I read it as negative 2, negative 4. Does that make sense?
Yeah.
Okay, so it's left to right, top to bottom. Any other questions? Okay, so that is how you do matrix multiplication by hand. You really kind of want to only go to this well if you have to, because if you have really big matrices, let's say you have a 3 by 2 times a 2 by 3, your product matrix is 3 by 3, that's 9 elements you're finding. So if you have bigger matrices, you're going to go to your calculator for that. Matrix multiplication, you may notice, not commutative. We didn't get A times B to be the same as B times A. Any other questions about this before I move on? Because I'm going to do another problem that helps you understand why matrix multiplication is done this way. Why is it that we're adding is usually the question we have. So I picked about inventory. We're asked to find total cost in this problem to kind of get us through the day here. Let me see. Make this a little bigger. Okay, so we'll read this together and we'll kind of talk about it a little bit. It says the school stores from the middle school and the high school each submit an inventory list for the year. Each sweatshirt costs $15. Each t-shirt costs $9. And each pennant costs $5. I'm supposed to use matrix multiplication to find the total cost of the inventory for each school store. Well, think about how we would get the total cost of the inventory, right? You'd have to take your number of items for each thing and multiply it by the number that represents the cost of each item. That's how you figure out that total cost. So not only do you multiply, but you have to add those values together in order to find your total. So this is a perfect problem for matrix multiplication. It would totally take care of finding those two numbers we need. So what they're asking us is to figure out, ultimately our answer is going to be the amount of money hanging out in the middle school's inventory, and then the amount of money hanging out in the high school's inventory. So what I'm thinking is that I should get two number answers for this problem. A number that's going to represent the amount of money at the middle school, and then a number that's going to represent the amount of money at the high school. Now, why am I setting this part up first? It has to do with what's written in this box right here. Remember, you have to set up the matrices so that the columns of the inventory match the rows of the cost matrix. Because if I don't set it up exactly like this, I get an answer that, well, 1, may not be able to be found, or 2, gives me 9 elements. But I needed 2 numbers to answer the question. How much money is there at the middle school, and how much money is there at the high school? So once again, the order and the setup is very important. If you mess that up, you're going to get an answer that doesn't make sense. And I gave you one of these to try tonight. So make sure that if you get the wrong answer, you're going to know it right away, because you're going to be like, that doesn't even make sense. Like, that doesn't even answer the question. So notice what I have here. I have a 2 by 3 matrix and a 3 by 1 matrix. So when I draw the eyeballs, I'm like, okay, look, this matrix multiplication, totally possible, because those eyeballs match. The number of columns in the first matrix matches the number of rows in the second matrix. And look at this. If I make my smiley face, I know it's quite large, but if I connect those dots right there, do you see my answer matrix needs to be 2 by 1? And I got a 2 by 1 matrix set up right now for my answer. The top number is going to give me the amount of money at the middle school, and the bottom number will give me the amount of money at the high school. So now I just need to fill in how many there are of each item. So the middle school has 61 sweatshirts at $15 a pop. They have 63 t-shirts and 74 pennants. And then 58 sweatshirts, 71 t-shirts, and 92 pennants. So if I'm doing this guy by hand, you know, we gave this a name. This is the first row, first column. This is the second row, first column. So to get my first row, first column element, I have to multiply 61 by 15, add that to 63 by 9, and then add that to 74 by 5. And then to get the high school's amount of money, I'd have to take 58, and those are $15 each. And then the 71 t-shirts at $9 each. And then the 92 pennants at $5 each. So I'd be going to my calculator for this problem anyway. So you might as well have keyed in the matrices there. But I'm going to go ahead and have you wrap up this lesson by finishing this problem here. and then the 2 independent practice problems that you have. And then, the wrong way. This one, I would do it by hand. This one, I would do on your calculator. And that'll help you wrap up today a little bit. You need to come around and check your homework from last night. Good job.